Alright, so here's a video for the Chapter 9 and 10 practice test for Math 10 PDP. In this assessment, graphing calculator will be allowed to use, so I'm going to use the graphing calculator accordingly. Let's look at each question one by one. Find the measure of angle B in the triangle ABC given that A is 47 degrees, lowercase a is 11 meters, and lowercase b is 9.6 meters. So the first thing that I would do is to write down the graphic organizer. So A is 47 degrees, uppercase B is unknown, and uppercase C is unknown. Lowercase a is equal to 11 meters, lowercase b is equal to 9.6 meters, and lowercase c is equal to unknown. And now we're looking for the measure of angle B, so let's call that x. Now one thing we notice is that because we have a full pair, a perfect pair, it means that we can use the sine law to solve this triangle, to solve this unknown value. The sine law goes like this: a over sine of a equals b over sine of b. And then let's plug in the values. A is 11, sine of 47 degrees equals x over equals 9.6 divided by sine of x. Now let's solve for sine of x. Sine of x is equal to, it'll be 9.6 sine of 47 degrees divided by 11. And then if I undo the sine on both sides, I get x is equal to arc sine of 9.6 sine of 47 degrees divided by 11. And then I'll put that into calculator. I'm going to make sure that my mode is in the degrees mode because the question gives me the angle in degrees. So let's do arc sine of 9.6 sine of 47 divided by 11. And I get approximately 39.7 degrees. Now, 39.7 degrees is not the only possible answer, because we could have the obtuse version of this, which I find by doing 180 minus that, which is approximately 140 degrees in 3/6. Now, I need to check the validity of the 140 degrees, which I'll do by adding the 47 degrees and the 140 degrees that I just found. And that's 187 degrees, which is greater than 180 degrees. Why it's important? Because it's greater than 180 degrees is that no triangles have the sum of the angles greater than 180 degrees, and 187 is definitely over that. So we know that 140 degrees is not going to work. Therefore, my only possible answer for the angle B will be approximately 39.7 degrees. Let's move on to the next question. Aaron ran 3 kilometers on the bearing of 220 degrees, then 2.5 kilometers on the bearing of 315 degrees. Find Aaron's distance and the bearing from his starting point. So, well, first thing we need to draw this situation. The bearing of 220 degrees is going, it's a bit more than, it's 40 more than 180, which is we're going south and a bit west. And then the bearing of 315 degrees, which means that it's a bit more than 270 degrees, 45 degrees more than 270 degrees. So it means that we're going west and a bit north. So I think it makes sense that we start with put Aaron's position perhaps around here on the right hand side. Let's call it A, or A1. And then let's draw the situation. The bearing of 220 degrees, which is once again 40 degrees more than 180. So probably like here. And that's A2. And that's 3 kilometers. The bearing of 220 degrees. And then we're going 2.5 kilometers on the bearing of 315 degrees, which is 45 degrees more than 270. So that's going to be around like here. Let's draw it as a bit shorter than 3 kilometers. Bearing of that is 315 degrees, and that's A3. Now, I'm not sure about the exact location, about whether or not A3 is below A1 or above A1, which doesn't seem to matter too much. But I know that A3 must be on the left-hand side of A1, roughly. And then should be close to 270 degrees. Now, my goal is to find the distance between A3 and A1, and also the bearing of A3 from A1. So, what kind of angle can I use? Well, the first angle that we can start with is the idea of using the 220 degrees here. So the bearing of A2 from A1 is 220 degrees, which means that it's 40 degrees more than 180 degrees, which explains that the bearing of A1 from A2 would also be 40 degrees. Also, we know that the bearing of A3 from A2 is 315 degrees, which is slightly shorter than the 360 degrees, which is going to be 45 degrees less than 360 degrees. So overall, we know that the angle A1, A2, A3 is going to be 85 degrees. Now, I know one of the angle on a triangle, and I know two sides of a triangle, so I think we can redraw this diagram to draw a better, easier version of this triangle. So let's draw one more triangle, this time a bit simpler. Let's go like that. A1, A2, A3, and then the lengths are 2.5 kilometers and 3 kilometers, and then 85 degrees. Now, let's use the graphic organizer to identify some stuff. A1 is unknown, A2 is 45 degrees, and A3 is unknown. And the length A1 is given as 2.5 kilometers, the length A2 is unknown, and length A3 is 3 kilometers. So this one, we don't see any perfect pair. So that's a good sign that we have to use the cosine law. And also, because we need to solve the unknown side using the cosine law, we're going to use the version where the c squared is isolated on the left-hand side. So let's copy down the formula. C squared is equal to a squared plus b squared minus 2ab cosine of c. So that's going to be x squared is equal to 2.5 squared plus 3 squared minus 2 times 2.5 times 3 times cosine of 45. Not 45, sorry, 85. And on square rooting both sides, and that's approximately going to be, using the calculator, and that's going to be approximately 3.73 kilometers. So I think that answers the first part of the question. Aaron's distance from his starting point is going to be 3.73 kilometers. Now the next question asks me to find the bearing of the Aaron from the starting position. We want to find the bearing of A3 from A1. Well, I know that the bearing of A2 from A1 is already 220 degrees, so I think that if I find the angle A1, let's call that Y, find the angle A1, then I'm going to add it to the 220 degrees, the bearing of A2 from A1, and then I'll find the bearing of A3 from A1. So how will I find such angle? Well, I think we already we already have a perfect pair, and without the perfect pair we can't use the sine law anyways. So I think I'll have to use the perfect pair of the 85 degrees and the 3.73 kilometers, and then put that with the A1 and A1. So let's use the sine law. A over sine of A equals B over sine of B. So in this case, let's go 3.73 divided by sine of 85 is equal to 2.5 divided by sine of y. So just to make sure, I'm not going to use the 3.73 as it is right now. I already have this 3.73 saved onto my calculator using the store button, and then I'll use that to find the value of sine yy. So sine of y is equal to 2.5 sine of 85 divided by 3.73. So y is going to be arc sine of 2.5 sine of 85 divided by 3.73. So let's put that into calculator. That's going to be arc sine of 2.5 times sine of 85 divided by 3.73, which is approximately 41.8 degrees. So I'm going to add the 41.8 degrees to the 220 degrees, which is approximately 262 degrees in 3 sec fix. So my final answer is distance is 3.73 kilometers and the bearing is 262 degrees. Let's move on to the question number 3. Points A, B, and C form a triangle ABC. So find the distance between A and C and hence find the angle ACB. So what I'm going to do here is, I know that the points A and C and B, A and B and C are in 3 dimensions, but that scale is not useful here. We don't need to draw in 3 dimensions, and it's difficult to draw it anyways. So I'm just going to randomly put the points A, B, and C. And then to find the distance between A and C, well, perhaps I can use, first I can use the distance formula to find the distance between A and C. So part A, we use the distance formula. D is equal to x1 minus x2 plus y1 minus y2 plus z1 minus z2. So that's going to be, point A is 3, -1, 2. So that's going to be 3, -1, and 2. And the point C is 1, and then 2, and then -1. Plug in the values, 2 squared plus -3 squared, that's 9, and then 3 squared, which is 4 plus 9 plus 9. That's going to be 18 for 22, square root of 22. So we know that the distance between point A and C is square root of 22. Hence, find the angle ACB. So in order to find the angle ACB, I think we're going to need to find some other distances as well, right? So let's find the distance between A and B, and also the distance between B and C, and then I'll use these values to use the cosine law. So I found the distance between A and B and also the distance between B and C. Now let's find use the cosine rule here. Well, first of all, given that we need to find angle C, I'm going to put that on the left-hand side. I'm going to use the second version of the formula, which is cosine C on the left-hand side. And also I'm going to make sure that the 3 is the C on the formula as well. In this question, we're going to make sure that none of the angles are given in this problem. So it means that we have to choose the unit, which means that we're going to have to use the radian mode in this case. So if I do the arc cos of 13 divided by square root of 13 times square root of 22, the radian would be 0.694 radian. So that's the angle ACB in radians, 0.694 radians. Moving on, question number 4. Given the above triangles, sum of the two shorter sides is 10 centimeters and find the perimeter of the triangle. So the sum of the two shorter sides is 10 centimeters. So that means that the x plus y is going to be 10, right? In most cases, dealing with two variables is not a good idea. So I'm going to represent y as 10 minus x. And so that means that instead of saying y, I'm just going to say 10 minus x here. Now I think we can use the sine law to solve this problem, because we already know the pairs, and we can see that easily if you put them into a graphic organizer here. The angle A is unknown, angle B is 48 degrees, angle C is 37 degrees, lowercase a is unknown, lowercase b is equal to 10 minus x, and lowercase c is equal to x. So none of the information is given about angle A and the length A. And we know two angles, so it means that the only option that we have is the sine law. So let's use the sine law. Now I'm going to collect like terms for the x values. I'm going to put x37 on the right hand side, x sine 37 on the right hand side. and then factor out x. And then finally divide both sides by the sine of 48 plus sine of 37. And let's put that into a calculator. For this one, we're going back to the degrees mode because the question is asking. It already gave you the angles in degrees. So I got x is approximately 4.47. The unit was centimeters, which means that the y was going to be approximately 10 minus of that. Which is 5.53. So using the two length here, I think I'll need to find the lowercase a, right? So let's use, I think we can use the cosine law this time to find the unknown side. The c would be the unknown side, let's call it a. And then we know the length b and c as well as the, well actually my bad, we can't use the, I guess we can find the angle a here and then by just doing the 180 minus 48 minus 37. Angle A is going to be apparently 95 degrees. So plug in the values. So I put that into a calculator. I got A is approximately 7.41. So adding all these values together, I got approximately perimeter A plus B plus C, which is approximately 17.4 centimeters. All right, moving on to the last question. A sphere has diameter PQ, where P and Q, the positions are given. Find the coordinates of the center of the sphere, find the radius of the sphere, and hence find the volume and surface area of the sphere. So the first thing that we need to do is find the coordinate of the center of the sphere. Well, we know that a sphere has a diameter PQ, which means that these 2 points, they do go across the center, and you know the diameter is just half the radius. is two times the radius. So I think find the midpoint of P and Q will help us find the coordinate of the center of the sphere. So how do we find the midpoint? Midpoint is given as midpoint as x1 plus x2 divided by 2, y1 plus y2 divided by 2, z1 plus z2 divided by 2. So I think the midpoint in the values will be 4 minus 6 divided by 2, and then negative 2 plus 2 divided by 2, 3 plus negative 5 divided by 2. So will be negative 2 divided by 2 will be negative 1, 0, and negative 1 once again. So the coordinate of the center of the sphere is negative 1, comma 0, comma negative 1. And let's find the radius of the sphere. You find the radius of the sphere by finding the diameter and then divide it by 2. Instead of using the midpoint here, I'm going to just use the P and Q here just to be safe. So once again, the formula for the distance is equal to x1 minus x2 squared plus z1 minus z2 squared plus, y1 minus y2 squared. And z1 minus z2 squared. So that's equal to 4 minus negative 6 squared plus negative 2 minus 2 squared plus 3 minus negative 5 squared plus 10 squared plus 4 squared plus 8 squared. 100 plus 16 plus 64, I mean, it sounds like 180. I think I can simplify that to 6 square root of 5, because 36 times 5 is 180. So we know that. Oh, sorry, my bad. So this is the diameter. So that means the radius is half of the diameter, which is 3 square root of 5. Now we know the radius. I think we can find the volume and the surface area of the sphere quite easily. The volume is equal to 4 over 3 pi r cubed. So plug in the values. So that would be 4 times 9, which is 36. 36 times 5 is, once again, 180, I guess. 180 square root of 5 pi. That would be the volume. And what about the surface area of a sphere? Is 4 pi r squared. Let's plug in the values. Four times 180, 725. Will be my final answer. Alright, thank you for tuning in for this video. Hopefully this video helps you to prepare for the upcoming Chapter 9 and 10 assessment.